Welcome back, everybody. In this video, we're starting up Chapter 2. We'll be looking at just a little bit of Section 2.1. Chapter 2 is about linear functions. As before we get actually into the content, we want to take a quick look at just what the chapter is about. So the chapter is about linear functions. There's a total of 4 sections. We've already studied functions in general and then somewhat of linear functions already. This is just more specialized to linear functions. So section 2.1 is also called linear functions. This describes what a linear function is, along with some of the basic characteristics of a linear function. 2.2 focuses specifically on graphs for linear functions and what kinds of things you can do with that. Section 2.3 has to do with story problems, essentially. In essence, whenever you see modeling, what is meant there is basically story problems. Section 2.4 we're going to skip. But it has to do with how if you have a set of data, you can create a linear model to somewhat fit that data. Read over section 2.4 if you're interested, but we are not going to cover it as part of this class. So we'll focus really on sections 2.1 and through 2.3. A lot of this stuff is going to end up being familiar, which is going to be nice, but then some stuff will probably be new, which is also nice. So let's go ahead and get into section 2.1. So we'll start off with just a definition of what a linear function is. A linear function is a function whose graph is a line, which makes sense if you think of the first 4 letters of the word linear. It spells out the word line, right? Linear functions can be written in slope-intercept form. F of x equals mx plus b, which is not surprising. You're used to already the equation of a line y equals mxb, the slope-intercept form. So it has the exact same structure. Okay, b is the initial or starting value of the function when the input x is equal to 0. And m is the constant rate of change called the slope of the function. The y-intercept is at the point 0b. It's worth noting also that for a linear function, the domain is always all real numbers. If you think about it, there's no way that we could accidentally try to divide by 0 or take an even root of a negative or any other kind of forbidden thing at this point. Okay, I wanted to mention also that you may see different notations for this kind of standard look of a linear function. We're used to seeing mx plus b, but there are other ways of expressing it. You might see a0 plus a1x instead. And the reason why you might see that, the y-intercept being a0 and the slope being a1, is that it generalizes easier to if you want to try to make a polynomial function of higher degree. For example, if we want to make a degree 2 polynomial, all that we'd need to do is add an a2x squared to it. And then you could guess if we want to make it cubic, we could say, okay, let's add a3x cubed to that. Then we can add as many terms as we wanted, right? If I just told you, okay, let's take f of x and call it mx plus b, where the coefficient of x is going to be m, and I said, okay, well, let's make something that has degree 2 out of it. What would you decide to call the coefficient of the squared term? Could be kind of hard to predict and probably wouldn't all necessarily have the same answer. So the short explanation is that if you write a0 plus a1x, it's going to generalize more easily to cases where we have higher degree. But for the most part, we will just go ahead and use mx plus b. If you do run across a0 plus a1x, it's going to have the same basic concept though, where a1 will be the slope and a0 will be the y-intercept. Okay, so in the next part, what we want to do is just decide whether or not we're dealing with a function that's linear or not. If it is a linear function, express it in the form ax plus b. So here they've used it as ax plus b. So they're calling the slope a here instead of m, but it's the same. Okay, so let's take a look. For 8, it says f of x is 2 minus 4x. If I write that as f of x equals negative 4x plus 2, then yeah, that looks a little more easy to see that it's a linear function. Okay, the square root of x plus 1, that is not going to be a linear function. Okay, we saw that the square root graph was curved, right? Like that, and adding the plus 1 shifts it up by 1 unit. So that's it. So it's definitely not a linear function. So here, f of x is 2x minus 3 over x. This one, the top part, the 2x minus 3 might look linear, but we do have a x in the denominator. So this one, f of 0 is undefined, right? And so it automatically has to not be a linear function. Because as we said, a linear function has domain all real numbers. Okay, here we have 1/2 times 3x minus 1. If we take and distribute the parentheses, we'll have 3/2 x minus 1/2, and that looks linear. So there we could tell by looking that it is a linear function. Okay, so let's continue. Okay, so a key characteristic of a linear function is that the graph is a straight line, and equivalently that the slope is constant. If you have a function that is increasing, as shown in the picture here, that would correspond to having a positive slope. If you have a decreasing function, that would correspond to having a negative slope. And then a constant function has a 0 slope. So we want to revisit the formula for how slope is calculated. And this part will probably be familiar to you. So the slope, which is the same as the rate of change for a linear function, is traditionally called m. It can be calculated using this formula. The change in the output, sometimes called the rise, divided by the change in input, frequently called the run. It's a quotient, so the division of the y change on the top divided by the x change on the bottom. The little triangle symbol, we've seen that before, that stands for change in. So when you see this fraction, you can read that as the change in y divided by the change in x. That notation is especially useful for situations where we don't really care what value of x we started out at, okay? So there's that. And then formula y2 minus y1 over x2 minus x1. If we think in terms of functions, our y2 could be our f of x2, and our y1 could be f of x1. So then the slope formula turns into this. Change in the function values divided by the change in x. So you can see that as change in f over change in x as well. All right, so let's calculate the slope. This is something that you should have done before in intermediate algebra, even if it's been a while. That's okay, but it should be mildly familiar. So we'll take m. That's going to be the change in y divided by the change in x. Okay, and so here I'll have 15 minus 5 divided by 8 minus 2. That will be 10/6. You always want to simplify that. That will be 5/3. Okay, it's important to note that the slope in going from 2/5 to 8/15 is the same as the slope going in the other direction. That is, here you saw that I subtracted basically right to left, 15 minus 5, then 8 minus 2. We could just as well have done both subtractions in the other direction. If we say 5 minus 15 divided by 2 minus 8, that'll be negative 10 over negative 6, which is still 5/3. So the slope is the same, regardless of which point you take to be first. You do want to be careful to make sure that you always have the y on top. Okay, so a frequent mistake people will make is they'll do the x change on the top. Another mistake people will make is subtracting backwards on just one of the numbers. So if you had 15 minus 5 divided by 2 minus 8, getting negative 5/3. Okay, here if you take a look at it, the subtraction was done backwards or inconsistently. One of them was left to right and one of them was right to left. Okay, so of course here, negative 5/3 couldn't be the slope of this line segment because just looking at it, it looks like it should have a positive slope, right? Okay, so now we'll calculate the slope of this line. So here, -1, 4, and 2, 3. If you think about it, it shouldn't make a difference what order we write the points down in, right? If you wrote down the 2, 3 first, we shouldn't get a different answer, right? So we could do the subtraction either way. We'll have the change in y divided by the change in x. So I'm going to go left to right here. We'll have 4 minus 3. That's the change in y is on top. And the -1 minus 2. Okay, 4 minus 3 is 1. -1 minus 2 is -3. So get -1/3 for the slope. That will do it. Just so that you can see how it looks, I'm going to go ahead and put the other calculation in as well. So doing it in the other direction, we'd have the change in y over the change in x. Still have the y change on the top. We'll have 3 minus 4 divided by 2 minus -1. You have to be really careful with negatives, right? 3 minus 4 is -1, and 2 minus -1 is 3. So of course we still get -1/3. Okay. All right, so that takes us to the end of this video. We'll continue with examples in the next video where we're finding equations of lines. Okay, in the meantime, let me know if you have any questions, and have a great day.